so dumb. I don't know anything about this.
Hey Arbin, what's going on?
Hey, Luke, I'm trying to work about parameterization of curves, and he has given a point, and he says to go counterclockwise. But I'm always used to being use x equals to cosine and y equals to sine. But in this case, it's just opposite, and I don't know how to start this parameterization.
Okay, so you're starting with a circle of radius 2 at the origin,
Yes.
starting at the top and going counterclockwise. So you'll start up here with your y at its maximum.
Yes. And
Y and x are both going to decrease
Yes.
and come all the way back around like that. Okay, so what function do we know that starts at its maximum and goes all the way down to its minimum and comes all the way back up? Something that
should be
goes like that.
that's cosine, right?
Yep, but that's our y. So
Okay.
we could say y is going to be 2 for our radius of 2 times our cosine of t, because that will get us starting up here and going down and back up.
Okay.
And then x is starting at 0. Do you know something that starts at 0 and does something like this where it goes down and up and up?
It should be sine, right?
Yep. But if we have x being just 2 sine of t, that's going to get us going this way, because when you look at the graph of sine, it goes up and then down.
Okay.
So how can we get it to go down and up?
Probably put up the negative sign.
Exactly. So if we put on that negative, we're going to get sine going like that. Down and up and up and down.
Oh, sweet.
And so that's how we'll get a circle starting at the top and going counterclockwise.
Sweet. That looks good.
Yeah.
So we did the circle, but I'm confused about the ellipse. What about the ellipse?
So the difference between an ellipse and a circle is just going to be that you've got 2 different radii. So say you've got an ellipse here, and it still goes up 2 in the y direction, but in the x direction it goes off 3 instead. And we want it to start at the same spot and go in the same direction. That lets us use these 2 similarly, but since we have a different radius for each of these, that's going to change our different coefficients out here in front.
But the sine and cosine remain same, right?
Yes, because we're still starting at the top and going
Down.
out and back in and out and in.
Okay. Sweet. That looks good as well. So my next question would be what's the point of using the circle and ellipse with parameterization?
Well, the thing is, parameterization of curves is actually really useful for a lot of other things. Because, say you wanted to have a graph that looks something like this. Now, you've got your x starting at 0 and going up to 1 and down to -1. So, you know something that goes like that. It's going to be our sine function again.
Yes.
But now we've got y, and that's just going up.
Yeah, it's going up. There's no
Normally
function
increasing.
like this.
So let's say that this point here where we're starting is at y equals 4. So when we've got t equal to 0, we've got y equal to 4. And then we're adding on more and more to our y as t increases. So we add on something related to t. And that's going to be related to how far out this is stretched. And when you get into Calc 3, it's going to be a lot of stuff like this, where you have to write equations in terms of one parameter, but you've got 2 different equations. Like you'll have y and z both being functions of x, and that'll give you something that could look like that. And so that's why we're working on parameterization of curves now, so that you're ready for that when you get into Calc 3.
Okay, sounds good.
Yep. Keep up the good work, Arbin.